modify what I have here. What can I do? Multiplying by 4 over 4, let's see, if I do that, so I'm not saying that's incorrect, but if I put a 4 over 4 here, notice I still have this issue that the thing that I'm taking the sign of doesn't match up with the thing in the denominator. Exactly. Okay? So the 4 over 4 might not be the best approach. What else might I try? How do I get the denominator thing to look like the thing inside the sign? Okay? We'll do all sorts of crazy stuff. Let's try this. We'll try it. We'll make it simple. We'll multiply by 3 over 3. And then what we'll do is we'll move the 4 out to the front. Okay, we'll swap the places of the 3 and the 4 in the denominator. And then they look the same, right? Okay. So this will give me the limit as theta goes to 0. And just switching the 3 and the 4 in the denominator, a sine of 3 theta over 3 theta. Okay. Now at this point, I can go back here and I can say, yep, that looks just like this function. That looks just like this limit with that extra 3/4 in there. And so when I evaluate, I can pull my 3/4 out. My limit on the inside of the sine of 3 theta over 3 theta. This limit right here from previous work is 1, and so the entire value is 3/4. Just like our guess at the beginning said. Okay. All right, good. Not bad. Okay. What's the second one here? Any thoughts on the value of that one? Off the top of your head? Yes. Is it 1? What? 1? Question mark, we'll see. Okay, we'll try it. We'll see what happens. Okay, might be 1. Why not be 1? See what happens. What can I do with this limit, the way it is right here? Again, if I was to try to just plug the x equals 0 in, okay, what's tangent of 0? Tangent of 0 is 0, okay? 0 over 0 still, so okay, yeah, who knows what happens here, okay? So I do get 0 over 0, so I need to do some work here. I need to manipulate things a little bit in order to try to evaluate this using some other method. Okay? Alright, so let's see what we have here. Limit as x goes to 0, tangent of 2x over x. In some way, what I need to ultimately do is utilize that limit at the top over there. I need to somehow get a sine of something divided by that something in order to really make an evaluation of this limit. Question is, I look at this, I don't see a sign running around anymore, do you? This tangent function is actually hiding our sine function. Remember, tangent is in fact sine over cosine. So tangent of 2x is sine of 2x over cosine of 2x. So what I'm going to do now is I'm going to take this, I'm going to make this substitution into my limit. When I do that, what comes out looks something like this. Let's see, sine of 2x divided by cosine of 2x, all of that divided by x. Right? And actually I'm going to make this a little bit, maybe look a little more complicated for just a minute. But I do this just to indicate sort of how we're going to rearrange this limit now. Okay? What's the next step that I should make at this point here? Okay? So the next thing I'm going to do, since I have fraction divided by fraction, I'm going to flip them over and multiply, and that hopefully will give me a simpler expression that I can work with. Do that, just to simplify it a little bit, limit as x goes to 0 of sine of 2x. I'm going to maneuver things around a little bit too. X cosine of 2x. That's what I have now. Okay. So, all I've done is I've just made this substitution for tangent and then just simplified things down to a state where hopefully I can start working with this limit in a real divided by the x. The x here was already in the denominator, right? The x was here from the beginning.
Oh, okay.
Okay? It's just followed our way through. I've rearranged it to emphasize where it's at. I can't just introduce an imaginary x out of nowhere. Okay? I have to make sure that whatever I do to the limit itself is not altering the value of 1. It has to be sort of multiplication by 1 or addition of 0 situation. All right, so now, what can I do from here? Okay, again, remember, in order to utilize that limit over there, that sine of theta over theta, the thing inside the signs and the thing in the denominator have to be the same. What are we missing here? We're missing a 2. So let's just add it in. I'll add a 2 here. Counter that by adding a 2 in the numerator. And when I do this, now what I'm going to get, hopefully, is a limit that I can actually calculate. So I'm going to pull the 2 out front. Limit as x goes to 0. I have a sine of 2x divided by 2x times a 1 over cosine of 2x. Now, I've split it like this to sort of emphasize what we should do next. All right. What should I do here now? Well, I have the limit of 2 multiplications, right? So just split that up into 2 limits being multiplied together. Okay? I know what the limit of the first piece is, right? What's the limit of sine of 2x over 2x? That limit's 1. What's the limit as x goes to 0 of 1 divided by cosine of 2x? Okay. Cosine of 0 is 1, and so this thing right here would evaluate to 1 as well. And when all is said and done, I have 2 times 1 times 1. Our limit value on this problem ends up being 2. You look, you're on my problem. I could make a meme reference here, but I won't. Not related to you personally. Oh, related to team activities. Oh, yeah. So. All right, so there we go. All right. Now, we still have this last one left to do. Okay. How should we go about doing this last one? Notice again, if I was to plug the 0 in, everything in the top would evaluate to 0. The thing in the bottom evaluates to 0 too. So, how can I go about evaluating number 3 here? What should we do?
Put it 1/2 out in front.
1/2 out front. So you want to pull that 2 out from the denominator? We can do that. There's no problem with that. We go ahead and pull out the 2 from the denominator, just rewriting this is 1/2, the limit as x goes to 0. Be an adventure here and see what happens. All right, so we pulled the 1/2 out. We're left with an x squared plus x plus sine of 2x, or 3x, or minus this one. All that now divided by x. Okay, where to from here? What's next? I want to evaluate that limit there. You know, it looks really awful because I got a bunch of stuff in the numerator, a bunch of stuff running around in conjunction with that sine of 3x.
Should you split it up from x squared minus x?
Yeah, x squared minus x over x plus sine of 3x over x.
Okay, so let's go ahead and instead of always trying to get to a single fraction, we're going to take this single fraction, we're going to break it up. We're going to break it up into multiple fractions. Okay? The way we do that is we just split off the addition and subtraction in the numerator divided by the appropriate denominator. So we're going to take x squared over x minus an x over x plus a sine of 3x all over x. All right, so we've rewritten our limit into a bunch of little pieces. And now what we're going to do, again, following our rules of limits, is we can just take the limit of each individual piece here and figure out what each individual limit is going to be. Okay? Now, if we do that, let's see, I write these all out. X squared over x minus the limit x to 0 of x over x minus the, or plus the limit x to 0 sine of 3x over x. Okay, so here are the limits that I need to evaluate now. Remember that 1/2 is multiplied across all of these limits. Okay, that 1/2 applies to all of these limits. So
Could you
that's
just
why I have
write one?
What's that?
Could you just write 1 for x over x?
Sure.
Instead of writing the whole limit thing, could you just put 1 in there?
Right, I know here that I can simplify this piece down to 1, and so this limit I know goes to 1.
Okay.
No problem there, okay? Evaluating them piece by piece, we would get there anyways, okay? So that's 1. What about the first limit? What's the limit as x goes to 0 of x squared over x? Well, again, using the same idea of what we did over here, if we simplify, well, let's see, the x cancels out with the squared, and I'm left with the limit as x goes to 0 of x, which is 0. So this limit goes to 0. Okay. So I'm breaking these down piece by piece. I'm evaluating them as I can by simplifying. And now I get all the way down here at the end, and I need to evaluate sine of 3x over x.
How are you canceling the square root of x? Is it just you taking x out of there?
Just factoring, yeah, factoring,
Okay.
right? Factoring, I'm going to cancel like terms in the numerator and denominator.
Okay.
Okay. All right, so what about that last limit though? How are we going to evaluate that one? What do we need to do? Okay. What I need to do is I need to get the 3 in the denominator, and if I do that, I need a 3 in the numerator. And I know that that piece on the outside there, I know that that last limit evaluates to 3 times 1, this limit 3 times 1. And so now, I look at everything I have. Let's see, it's 1/2 times 0 minus 1 plus 3, which gives us value of 1.
I know what last one, you multiply by 3 over 3.
Right, I multiplied by 3 over 3 to get that extra 3x to match what was inside the sine
Would
function.
you not need a 1/3 though?
Why would I need a 1/3?
Because if you multiply by 3 over 3, your numerator, your 3 over 3 will go out, and the denominator of 3x will go out, but you can still retain.
The 3x had to come in. That's where we needed to get the 3. It started with just the x, right? So yeah, we put the 3 in the
Oh,
denominator.
sorry.
Yeah, so.
How does x over x equal 1 with x over,
X squared over x equals 0.
yeah? Because if you put 0 in for the 2 x's,
You're right. If you were just to plug the 0 in, over here you get 0 over 0.
yeah.
Over here, you also get 0 over 0.
Yeah.
Okay? The idea behind this is which one of these zeros is really getting bigger faster? Which one of the zeros here is sort of dictating which way this value is going? Okay? In this case, you have a 0 squared at the top. Just a 0 to the first power at the bottom, right? Which one of those is getting smaller faster? Which one gets closer to 0 quicker? If you take things that are very close to 1 and you square them, sorry, if you take things very close to 0 and you square them, what happens to them? Do they get bigger or do they get smaller?
Bigger? Or smaller?
Right, so if you take something like 0.1 and you square it, that's
Okay, yeah, smaller.
0.01, right?
Yeah, yeah, yeah.
So the things on this one, the things in the numerator are getting closer to 0 faster. They're being driven down to 0 faster. And so the 0 in the denominator doesn't have time to catch up. It doesn't have time to catch up and sort of cancel out that behavior. And so that's why this particular limit goes to 0, is because the extra x in the numerator is causing things to get smaller much quicker. Okay. Over here, these two things are sort of canceling each other out as they get closer and closer to 0. Ha, I'm 0.1. Ha, I'm 0.12. Ha, I'm 0.01. Ha, I'm 0.012. So they're canceling out in that case, and that's why that one gets closer.